you're watching this, that means that you've already seen the Brightstorm video on flowchart proofs. I want to show a couple of other examples of using flowcharting on proofs, and then you're going to be doing some on your own. And one thing I want to mention about flowchart proofs is that it's not specific to geometry. This kind of information can be used in almost any field of study, from English papers, history essays, even science lab reports, because all flowcharting is a way to organize your thoughts in a systematic manner that's easy to comprehend. And so that's really what we're going to be doing. So before you actually write the proof, of course, you have to think about the diagram of where you start and where you're supposed to be going. And then you just put the information into the proof as you figure it out. So let's take a look at what we're supposed to prove and what we're given, and then we'll see what we can do with this flowchart proof. Well, you know that you need three things that are congruent. They have to be the right things, and they imply then that the triangles are congruent. And once you get triangles are congruent, then you know that all of their other parts, the parts that you didn't know anything about, are also congruent. So we start from what we know to get congruent triangles, and then we know even more about those triangles. I mean, otherwise we can guess, but we don't know for sure. So this is what the proof is about. Sometimes we need another box after this because we're not done with the congruency here. We maybe have to prove something else about it. Or sometimes we need something on this side because we don't have congruencies given. Let's say we have parallel or something else given, and we have to get the congruencies with another step. But this is the basic skeleton for the proof. So what we have here is in this proof we have side AB and side DC are congruent. And likewise, the angles at the bottom here, angle BAD, is congruent to angle CDA. And the idea is to try to prove that the two diagonals here, CA and BD, are congruent to each other. And so, since those sides are parts of these larger triangles, the triangle BDA and triangle CAD, what we're really working with is those two triangles. And that gets a little confusing because of all the other sides and stuff that are in the drawing, and it can be confusing. So what you can do, if this is on a sheet of paper, you can, on a worksheet or some other, in a book or something, you can use a piece of patty paper and trace over the triangles that you're actually dealing with, and then make them side by side or one above the other, and that sometimes can clear things up. So what I'm going to do is I'm going to take the triangle ABD here and put it down here, like so. And I'm going to take the triangle CDA here, which is the other triangle we're dealing with, and put it down here and mark it appropriately, so that now we have our two triangles. Instead of being confusing looking here, they're separated and it's easier to look at. And we can see from this drawing that we're given AB and CD congruent, and the angle at A and angle at D congruent. And then it's pretty obvious just by looking at this that they both share side AD. And that's going to be the third thing. And if you take a look here, it's going to be side, angle, side, because we have the two sides and the included angle. You have to be careful that you don't just use any two sides and angle. If it would be, for instance, side BA, side AD, and an angle at D, it wouldn't work, because that would be SSA, and SSA doesn't work. So you have to be careful, make sure it's one of the three-letter combinations that do work. And in fact, this one is. So we already have our plan. We see that the two triangles are congruent because of SAS, and that's really what we need to write down. So the first thing to do then would be write down what we're given here. This isn't going to work perfectly. Well, let's do it this way. We're given AB is the same length as CD. So I'll copy that over here and and paste it in. And we're told that angle BAD is congruent to angle CDA. And both of those, of course, are given. So I can write underneath here, I can write given. And then the last thing I can write is that AD is the same length as DA. And notice the way I said it. I said AD equals DA. It's important to write them down in the same order. And if I say AD, I'm going from the marked angle to the unmarked one. So I have to go from D to A and say D. I can't just say AD congruent to AD. This should be both. It should be written the same way because we're talking about corresponding parts here. And that, of course, is because it's a shared side. Now, the actual reason is reflexive property, like a reflection. Like one's a reflection of the other. In fact, it kind of looks like would be. But I'm just going to call shared side. You should always look for a shared side because that's one of the main things that we use to get the triangles congruent as a third side that's shared. Or sometimes we also use vertical angles. So always look for vertical angles and shared side as your third thing. And then, of course, we already said that the two triangles are going to be congruent, so I'll just write it this way. Oop. Triangle ABD. I'll have to do some erasing later too. Is congruent. I'll grab my congruent thing up here. To triangle DCA. Notice since I said ABD, I gotta say DCA because you want to make sure it's in the same order. Oh, what happened there? Better change those to and that, of course, would lead, if you take a look here, then we had to prove that CA and BD are the same length. Well, CA and BD are the corresponding parts of congruent triangles. So we can say what we wanted to prove, CA equals BD. And of course the reason for that would be CPCTC. And again, the Brightstorm video talked about that. That stands for corresponding parts of congruent triangles are congruent. And there we have our proof. It's really just, again, a way to organize information that we already figured out about the picture. Just have to organize our thoughts so that it makes sense. It tells you the three things, the triangles, and then what that proves.